In this video, we're going to talk about the trigonometric form of a complex number. The way we're used to dealing with a complex number is we usually like to see it in the form a plus bi, where a and b are real numbers. What we're going to talk about here today is we're going to rewrite them as r times the quantity cosine theta plus I sine theta. So our a, our real part from before, is going to be equal to r cosine theta. Our b from before is going to be written as r sine theta. Okay, r is going to be the square root of a squared plus b squared. And we know that the tangent of theta, the angle that it makes, is going to be b over a. R is what we call the modulus of our number. Okay, and theta, actually, draw my arrow down here, is what we call the argument. Now, when we write a complex number in this form, understand that it's not unique. Tangent of theta equals, let's say, 1, for example, at an infinite number of places. And so this argument is not unique. There's an infinite number of ways I can write this same complex number using r's and thetas. And using the modulus in the argument is what's considered polar form of our number. But we're not going to talk about polar form in detail until we get to chapter 6. So I think next week, maybe the week after. So don't worry about using phrases like polar form. Okay. What we're going to practice in this first video is going back and forth between the way we're used to seeing that number and writing it with the modulus and the argument. And here's how we're going to convert things. So let's say that we're looking at the number, negative 3 minus 3i. And I'm going to call all of mine z. I don't know that you have to give it a name, but I'm going to call mine z. Now, if we want to talk about, we need r and we need theta. So r is going to be the square root of the real part squared, my a squared, plus b squared. And the square root of 9 plus 9 is the square root of 18. I'm always going to simplify those radicals if they simplify further. And so we're going to call that 3 times the square root of 2. Now to find theta, we know that tangent of theta is b over a. It's kind of boring because they're both negative 3, so that the tangent of theta is equal to 1. Now when we're determining what theta is, yes, we're going to use arctangent, the arctangent idea, but I have to be really careful here. If I'm looking at, maybe I'll scoot my picture down here. If we're looking at the complex number negative 3 minus 3i, understand that that's a vector in the third quadrant. And so while the tangent of theta is 1 at a 45 degree or a pi over 4 reference angle, if I'm in quadrant 3, I have to add that pi over 4 to pi. And my theta here specifically for this complex number is 5 pi over 4. Okay, now yes, I could write that as a negative angle if I wanted to come this way, or I could add 2 pi to it if I wanted to wrap around. That's where the infinite number of options comes from. Now, most common convention says usually we're just going to pick the value between 0 and 2 pi. 0 inclusive, not 2 pi, and write it using that value of theta. So our r is 3 square root of 2, and we have cosine of theta plus I sine theta. Now this is the expression we're going to circle. If it says write the trigonometric form of this complex number, this is what we're going to give them. Yes, I know what the cosine of 5 pi over 4 is. It's negative square root of 2 over 2. But understand if I if I actually evaluate this, then I'm back to where I started here, at negative 3 minus 3i. Okay, so we're going to leave this, even if these are angles where we know what those values are. In the box there, that's what I'm going to give for trigonometric form. So let's say that z is equal to 1 minus the square root of 3i. At your desk, I want you to find the r. I want you to find the theta, starting with tangent of theta. Okay. When you're figuring out what angle we have, you have to come back to here and think about which quadrant you're in so that you pick the angle that's in the right quadrant. And then write your complex number as your r times cosine theta plus I sine theta. So we'll fill in blanks here and here and here. Go ahead and pause the video, give that a shot, come back when you're ready to see. Your r is 1 squared plus negative square root of 3 squared. So 1 plus 3 is 4, and the square root of 4 is 2. The tangent of theta is b over a. And if we are right 1 and down square root of 3, we are in the fourth quadrant, which means our theta is 5 pi over 3. When we come to fill in our blanks, our theta goes here both times. Our r goes out in front. We leave it factored out. And here is our complex form, if I can find what I need. Whoa. And then booger it up anyway. A complex form of, trigonometric form of that complex number. Now, it's kind of boring, but go ahead at your desk, find me the trigonometric form of z equals negative 3i, so the real part is 0, and z equals positive 6, where the imaginary part is 0. Okay, so do these, turn the video back on and see how you're doing. So r here should be 3. The tangent of theta is negative 3 over 0, which is undefined. If we're thinking about where that vector would be, we're at 0, negative 3, we're straight down here, which means we're at 3 pi over 2. So the r is equal to 3 out in front, and the theta is 3 pi over 2. Here's our trigonometric form of negative 3i. Do the same thing for z equals 6 if you haven't. Alright, so r is going to be 6 here. The tangent of theta is 0 over 6, which is 0, and since we're straight to the right, that's an angle of 0. So here's our trigonometric form of that vector, or that complex number. Now, in the next video, we're going to go the other direction. I was hoping to get them all into one. Maybe I can scramble, keep it to a couple minutes. Maybe I'm told z is 6 times cosine pi over 6 plus I times sine pi over 6. And I want to write that complex number in its regular standard form, a plus bi. The cosine of pi over 6 is square root of 3 over 2. The sine of pi over 6 is 1/2. If we distribute the 6 through now, we get 3 square root of 3 plus 3 pi. Okay, first quadrant. So maybe I have 4 times the quantity cosine of 2 pi over 3 plus I sine 2 pi over 3. And then 2 more are going to show up here. 1 more is going to show up in just a moment. Okay. So here are 2 I want you to practice at your desk. Find me the a plus bi, just our regular standard form of that. Pause the video and come back when you want to see the answer. Cosine of 2 pi over 3 is negative 1/2, and the sine is positive square root of 3 over 2. And when we distribute, we're here. Okay, 2 pi over 3 is an angle in the second quadrant, so you should always double check right here to make sure you have your signs right. Left 2 and up a little bit, that would be a second quadrant vector. 225 is in the third quadrant, and so I will go left and down to get to that value, and so I'm in the right place. That can help me catch a mistake if I've made one here with my signs. All right, next video we'll do some more.